And what we have here is we're going to now solve a function. We're actually going to create a function by using the different limit values that they give us. All right, the different characteristics of what this function is going to look like f of x. This is in one of the textbooks is number 50. But what we have are all these different descriptors that will tell us about this function f of x. So I'm going to just draw my axes. And we're asked to create an equation that will satisfy all these different values. So first off, when I do problems like this, I always start like one by one and just see what we got. So first off, we have the limit of f of x as x approaches 2, and that's going to equal -1. Well, what does that mean? Well, we're approaching 2, and what's happening is that this limit's going to -1. So what that means is that we're going to have some sort of value. We don't know if it's continuous or discontinuous, but we do know that there's going to be a value at 2 is going to equal -1. So what I usually do is I'm going to just put an open circle with the understanding that we are approaching, as x gets closer to 2, our graph is going to be approaching -1, which I drew right there with an open circle. You could have it filled in if you wanted to, but that's going to be a point of contention for whatever you want to do. It doesn't matter either way. The next thing we're going to do is I'm going to check out what's happening for this. I'm just going to go down the list. We have the limit of f of x as x approaches 4 to the right. And as we said, it says it's going to -infinity. Well, if you're approaching a value and it goes to -infinity, that limit's -infinity, we know that this is going to be a vertical asymptote, right? It's a vertical asymptote. So right here at 4, I'm going to create some sort of vertical asymptote like that. No. That's what I like to do when I do vertical asymptote. So what's going to happen is right here, as we approach 4 from the right, we're going to create, it's going to go to -infinity, and we have like so. We can see then as we approach to the left of 4, it's also going to go to infinity. So that's also going to be other side of the vertical asymptote. So right here, actually I'm going to connect starting at this point, and it's going to go up to infinity. So as I approach 4 from the left, that's going to go to infinity like so. So I'm just going to connect that dot like that, and it's going to go up. All right, let's continue. Looking here, now if you don't know, this is infinity. All right, well, infinity, the limit of f of x approaches infinity. Well, this right here, since we're going to infinity, this is end behavior, which is also going to be a horizontal asymptote, potentially. Well, we realize that this end behavior is going to infinity, so I guess it's not a horizontal asymptote, so we'll cross that out. All right, but we know that right here, as this gets larger and larger, continue on my graph, going from my vertical asymptote, I will now be diverging to infinity, and we can just run an arrow indicating that. Continuing on, we see that we're going to -infinity. Okay, -infinity, once again, horizontal asymptote, unless it goes diverges again on us. But this one is going to 2. Okay, so that is a horizontal asymptote. All right, so we're going to go over here, 1, 2. Draw a little line. All right, and continuing on from our point, because they have to be connected, all right? I'm just going to go down a little bit. It doesn't matter how you do this. I can go up and down as much as I want. But all I know is as we go to -infinity, this graph is going to be, converging on the value of 2. And this is how you do problems like this. You're taking the information they give you about limits, and we're just creating a function, that satisfies this criteria. The stuff in the middle, like you say, you do it like the up and down, like it doesn't matter as long as we fulfill that we have a limit as x approaches 2. It's going to be -1, which I have right there with an open circle. I have a vertical asymptote, so as I approach that vertical asymptote from the right, it's going to -infinity, which I have right there. As I approach it from the left of -4, it's going to +infinity, which I have right here. I then have a diverging, end behavior, so I'm just going to connect that there. And then we have another end behavior, which is a horizontal asymptote going to 2. All right, hopefully that helps you out on how to graph, create different functions, given different characteristics using limits. Good luck and God bless the rest of your problems.